All right, let's take care of part B. So we have this nice greenish region, turquoise region, so R2. And we're going to revolve R2 about y equals 1 line. Here we go. This is y equals 1 line, the dash line. Okay. So R2, the region is bounded by the red line and the blue curve. So red line is, let's see, y equals x, and the blue curve is y equals x squared. And y equals 1, that's where, that's the axis that we're going to revolve everything about, is horizontal. So we're going to take a vertical slice, which is per to the axis of the revolution, and we're going to revolve it around, and I think that's going to look like a washer. Okay, so let me use a different color here. So here we go. After you revolve this around, and this, let's say like this comes with thickness dx. Okay. All right. So let me just clean the other parts because we're gonna need we're gonna need writing down the little r, inner r, and outer r. So who is the little r? Well, let's label this as like little r. And here, for this specific slice, here is the capital R. Okay. And let me also clean these slices. Okay. All right. Woohoo! So let's see what. Well, first off, from here to here, it's always 1 because that's the distance between y equals 1 line and the x-axis. Okay. So the bottom part of the slice touches the curve. So let's say that this is x units far from the distance between the slice and the y-axis is, let's say, x. So that this height here is, in fact, what the blue curve is, x squared. Okay. If that's the case, r is going to be the whole distance from x-axis to y equals 1 minus x squared, which is going to be 1 minus x squared. Okay. R equals capital R. The outer radius of the disk is going to be 1 minus x squared. Okay. So let's check what this distance is. Let me just clean this part. I want to write down what this distance looks like, and that is determined by the red line, which is y equals x. So essentially, if that slice is x units far from that, the corresponding top edge is x units far from the origin. Far from, in fact, the x-axis, not the origin. Okay. But I need little r, thinking that the distance between x-axis and y equals 1 is just 1. And this distance is already equal to x, right? So little r is going to be 1 minus x. Okay? So for that representative disk I sketched earlier is going to come with the volume, pi, capital R squared minus little r squared dx. Right? This comes with thickness dx. Okay? And that's equal to pi 1 minus x squared squared minus 1 minus x quantity squared times dx. Okay? All right, if this part is clear, let's move on and write down the volume integral. And in fact, just for your reference, all the x's in the green region are ranging in between 0 and 1 for x. So I'm going to write down the volume integral as like pi integral from 0 to 1. 1 minus x squared squared, right? And then 1 minus x quantity squared dx. Okay. So let's simplify this definite integral. 1 minus 2x squared plus x to the fourth minus 1 minus 2x plus x squared dx. Okay, this is, by the way, part B. All right, let's simplify this. Pi, and I go from 0 to 1. This one cancels this one. Okay. You have minus plus 2x, minus 2x squared minus x squared minus 3x squared plus x to the fourth dx. Okay, so now we can find the antiderivative. X squared minus x cubed over 3, but 3 times that is just x cubed, minus x to the fifth divided by 5 from 0 to 1. Okay, so let's plug in the upper limit. 1 minus 1 plus 1 over 5 minus, if you plug in the lower limit, it's going to be pi times 0. Okay, that's 0. And then these ones cancel. So you have the total total volume of that region revolved around y equals 1 is equal to pi over 5. Okay. All right, this takes care of part B. So why don't you move on to part C, my next video. I'll see you there. Bye.